Dye-sensitized solar panels are part of the new third generation of technologies aimed at harnessing energy from the sun. 3G Solar, a technology venture funded by 21 Ventures, delivers low-cost solar energy solutions that produce electricity in low-light conditions and enable small-scale, cost-efficient production of dye-sensitized solar panels. Dye-sensitized solar panels produce as much power as silicon and thin film technologies, but can be assembled using a manufacturing infrastructure that costs far less than the manufacturing infrastructure required by silicon or thin film panels. This enables dye-sensitized cells to be built in much smaller plants and in diverse locations where off-grid solutions are urgently needed. Now, let's take a closer look and see how dye-sensitized solar panels make electricity from the sun. Photons, in the form of sunlight, collide with the solar cell and create an electrical current. On a nanoscopic level, the dye-sensitized cell is rather complex. Let's have a closer look. The top and bottom layers are protective glass with conductive coatings. Electricity in the form of electrons flows in and out of these conductive coatings, while the electrical production process happens in the middle layers. To understand what goes on in these middle layers, we need to zoom in to the molecular level. The photon strikes a dye molecule absorbed on the surface of the titanium dioxide, causing it to go into an excited state, and it releases an electron into the titanium dioxide that exits from the cell by way of the conductive layer. This electron passes along a wire and goes to do its work. The electron returns to the cell and re-enters the cycle by way of the bottom conductive layer. With the help of a catalyst layer, the electron enters the electrolyte and interacts with the triiodide molecule, reducing it to an iodide ion. The iodide ion makes its way towards the activated dye molecule and transfers an electron to the dye. The iodide ion returns back to the triiodide, and the dye molecule reverts back to its previous unactivated state. The dye is now ready for the next photon from the sun. This process occurs billions of times per second in the cell and creates an electric current. The sun bombards our planet at a constant rate of 174 petawatts of energy. 1 minute of sunlight on our planet's surface releases more energy than the world's population consumes in a year. With companies like 3G Solar bringing down the cost of solar power, it's only a matter of time before we start looking to the sky instead of the ground to solve our energy demands. You can find out more information about 3G Solar by visiting our website at www.3gsolar.com.